So, just to get your brain warmed up on a Monday, this is already a bad problem because it doesn't say something important. Have you learned that there's two ways you can end, either by giving me two answers or by giving me all the answers? Now, unless it says something, it doesn't say anything up there, then I guess you default to giving me all the solutions, which means you find the two answers and you slap a plus 2 pi k at the end of those answers. All right, so I'm going to just kind of like work through this one with you. George, can you tell me where sign is positive? We got the A, the S, the T, and the C, which is the same as quadrants 1, 2, 3, 4.
It's positive in the S and the A.
Yep, so I'm going to put my triangles in here and here. You should too, because sign is positive there, and it's negative down here, so those are out. Sign's opposite, hypotenuse, all these little things you have to know. Then you have to know that the key angle's right there. And then that's across from that. And I know that that means it's the bigger of the two sides it could be across from. And so it's the bigger angle. So it's not pi over 6, it's pi over 3. Who had that before I said it? Excellent. And then this one's not 3 pi over 3. That would be here. It is 2 pi over 3. Now, what did I just say a second ago? I said that it didn't tell me to only give answers between 0 and 2 pi. So then, I'm going to remind you what this really means. Sine is a wave that goes like this. And what they just asked you to do was find when it was equal to, not 1, but like something between 0 and 1. So there's infinite answers. We just found this one and that one. And if you add 2 pi to it, you'd get another one. And if you went over there, you'd find another one. So you can keep adding 2 pi, any number, which is k, times. So 2 pi k. And this one plus 2 pi k, because it did not say to only give two answers. Or only the answers that are less than 2 pi. It didn't say that. So, all right. Now, I did that one. Would you please do these two? Same rules. Didn't tell us to limit it to 0 to 2 pi. So if it's got an answer, slap a plus 2 pi k on it. Now, both of these are not quadrantals. That might have been a bad plan because quadrantals are so different. But for right now, it's just a whole bunch of triangles you're going to draw. I'll pause for a second. I'll answer these two. And then you check with the kid next to you to see if your answers for 2 and 3 are the same. Okay, if you haven't already, would you please just turn and discuss 2 and 3? Maybe you don't know how to do one of them. Talk to your partner.
If it specifies it, then just say the one thing. Yeah, if you see...
I'll actually show because I want to show up here anyway.
Okay, perfect. If you see that, it means that you're going to take this off. But if you don't see that, then you do it. That's what I was...
If the directions had said this, we would have only given the two angles. But since it didn't say that, we have to default to then I guess you want all the angles. So then you add plus 2 pi k. All right, so cosine is positive, so it must be here. And the other place cosine is positive is there. And so ASTC, cosine is positive there. All right, so then I go cosine is adjacent, hypotenuse 1, 2, and this must be square root of 3, again across from the square root of 3, and so that's pi over 3. And then this is a whole bunch of pi over 3's. I like to go all the way to here and say that would be 6 pi over 3, and then I back off one and say, so then this is 5 pi over 3. Raise your hand. Wait, plus 2 pi k. And plus 2 pi k. Raise your hand if you had that one right. Okay, awesome. And then lastly, this one, tangent is negative. So then it's A, S, T, C. And if tangent's negative, it can't be here or here because that's where it'd be positive. So then I draw it here. TOA is opposite, adjacent. And one of them's got to be negative. And if I think about it, that's the negative one. And then this must be the 2, and that makes sense to me. Across from the 1 is a pi over 6. That's the smaller size angle, but that's not actually pi over 6. It's 5 pi over 6. And then you keep going all the way to where there'd be another triangle here. And I like to go all the way and say that'd be 12 pi over 6. So then this is one less than that, 11 pi over 6. And then, once again, plus 2 pi k, because we don't have the direction to keep it to just 2 answers. Or just less than 2 pi. So there we go. Can you please verify? I sometimes make mistakes, but is that what you got too? Okay, good. All right, and then this next kind says hint reciprocal. All right. Would you agree that I told you not even to try to do cosecant, but right away change it to the sister function? So do you remember what the sister function is? That'd be a key part. Got to remember that sine is the one that goes with that. And then it's not just the same thing. We just changed the function. So we got to change the sides they gave us. So we got to change it to 1 over negative root 2. And the negative could be on either spot. And once again, I go through the process. Sine is positive, or no, sine's negative. So it can't be here. It can't be there. And then I draw my triangles here. And I think that'd be pretty easy from there, wouldn't it? The only thing that's tricky is that you flipped the angle, not the angle, sorry, you flipped the sides and you flipped the function. All right, let's go back to this one. Secant equals 2. Without my help then, give that one a shot. I'll pause for a second and give that one a try. All right, so here's how I would do it. First off, secant, I wouldn't even do secant. I would use a double arrow like this to show it's not equal, but it's changing to. You don't have to write that, but you know that secant isn't equal to cosine, right? But it's changing to it. And then 2 isn't equal, so I'm not going to put a equal sign. I want to put a double arrow. That's a way to say I'm changing this to 1/2. And then cosine of 1/2, cosine's positive, ASTC, cosine's positive over here and here. And cosine's adjacent over hypotenuse, and then this must be square root of 3. Cross from square root of 3 is pi over 6. Nope, pi over 3. And then it's a whole bunch of pi over 3s. 3, 4, 5, 6. Back off 1 is 5 pi over 3 plus 2 pi k plus 2 pi k. That all make sense to you? Okay, cool. So now we've got the ones that are called reciprocals handled. Let's go to the next part of the notes. This is called linear. Linear means that they're not quadratics at the end. At the end of solving this, it's just you get typically one equation instead of 2. See, when they're quadratics, you'll have like a squared in them, and you got to factor them usually if it has a squared in them, and then you typically get 2 parts to your answer instead of just 1. All right, so since there's no squared here, I'm just going to start thinking, okay, I'm trying to get the function alone, not just x. I'm trying to get cosine of x alone. Well, there's cosine of x's on both sides. So same thing if you had an x. If this had been 5x plus 1 equals 4x plus 2, you would have said, well, there's x's on both sides. I better get rid of one of them. So you're going to subtract 4 cosine x from both sides. Technically, you could have subtracted 5 cosine x, but you would have left yourself with a negative that you wouldn't have to have. So it'd be smarter to get rid of the smaller one. And then you're trying to get this alone. So Garrett, what happens next? Right here, what do I do next? Correct. Now I got cosine x equals 1. And yay, we're finally going to do a quadrantal. You know how I know? Because I right away put this over 1, and then I go opposite and hypotenuse, or in this case, adjacent over hypotenuse. Oh, the hypotenuse is the same as another side. That doesn't exist. So then it must be x over r, and hopefully you can find the right spot. Go ahead and do that. Completely different kind of problem. And in a second, let's see which quadrantal, or sometimes 2 quadrantals, you picked. Usually the ones that have two answers involve a 0. Nate, do you know a spot where X is 1 and R is 1? Right here? Is that what you're saying? All right. The radius is 1 there, yup. And the X is 1 there, yup. So then it's just 0. Could I put 0 degrees? No, just 0. Because 0 degrees is in the wrong units. We want radians. All right. And now down to this one without any help from me. Everybody please do number 2. It's very similar. Okay. How did you start? Jack, how did you start?
Subtracting the 3 sine.
I agree. And that cancels that. Not all of it. The negative 5 comes down. And then that is 2 sine x. Jack, what's next? Add 4. Add 4. Negative 1 equals 2 sine x. Now what? 5 by 2. And now that's negative a half. And then that is one of these deals. And sine is negative. Sine is down here. And sine is opposite over hypotenuse. And then there's a negative in there somewhere there. And then this must be square root of 3. And it's also negative. And then if I do this one really well, I won't have to draw the other triangle all detailed. I can just assume. Okay, so that's a whole bunch of pi over 6. Is that 6 pi over 6? That would be 7 pi over 6. And then it didn't say again, so I'm going to put plus 2 pi k. I probably need to do that on the whole test unless it says between 0 and 2 pi only. And then this would be 11 pi over 6 plus 2 pi k. I may have forgotten to put plus 2 pi k on a previous one, but I so far haven't seen any restrictions that tell me I can only give 2 answers. All right, so now the quadratic kind. Please turn with me to number 1 of the quadratics. Greta, I bet without any help, you can tell me how to unsquare something. Yeah, factoring is awesome, but we'd have to, and this will totally work. But we got to set it something first. I can't just factor it right now. Yes. Now, everybody wait just a second, and I'm going to show you this, because I know some of you are like, wait a minute, I thought you were going to square root it. And I can, but I just want to show you her way that she said to factor it is totally correct, and it's even better than the other way. Let me show you why. Because you would remember then that there's sine x plus 1 and sine x minus 1, which means there's 2 answers. Do you get a lot of kids just go square root, sine x equals 1, and they forget, and I even forgot one time when I showed you this in class sometime last week. I remembered after you left, oh, I forgot absolute value. When you square root something, you need an absolute value, and that's what gives you the plus and the minus. See, doing the factored way is better. That's why I say if you can do the factoring, you should, because this other way, you would have probably forgot the absolute value thing. So you would have forgot to make 2 equations out of it. Sine x equals 1 and sine x equals negative 1. And that means you have multiple answers for this thing. So again, this would make it more clear that there are 2 separate answers. Nate, you had a question at one point. Do you still have the question, or are we good? You raised your hand for a second, and then it went away. Good now? Okay, good. Okay, so now I have got sine x equals negative 1 and sine x equals 1, and I'm going to get 2 sets of answers for that. Those are quadrantals. Remember, sine is the y over the radius, and at all the quadrantals, the radius is 1, so that's kind of irrelevant. It's mostly just y. Where is y? 1? Right there, pi over 2. Where is y negative 1? Down there. 3 pi over 2. And this one was pi over 2. And then again, they haven't told me any directions, so I'm going to go with plus 2 pi k. If they said to keep it under 2 pi, I wouldn't do that. All right. So this one is going to come out very similar. It is faster to go square root, but you got to remember that it comes out positive and negative. So this is absolute value of tangent. X equals square root of 1 is just 1. That will split into 2 equations. Go ahead and solve that one. This one is not quadrantals. Very common mistake. Because tangent is y over x. Opposite over adjacent. I'll pause while you try that. Okay, let's see how you did. Cosine is positive, so then all students take calc, and these two are the ones where they're positive. So now this is out, this is out. Cosine is adjacent. Hypotenuse. It's a 1. Ooh, what's across from a 1? 30. What's the same as a 30? Pi over 6. That's pi over 6. And then this other one is a whole bunch of pi over 6. 6, and then 12 pi over 6 would be too far, so that one, 11 pi over 6 plus 2 pi k, because I want to really pound in that part. Okay? And again, if you look at the key for this thing, it probably doesn't even have that, because the teacher probably meant to say between 0 and 2 pi, but they didn't. So, and then here's cosine is negative this time, so it can't be here, and it can't be here. Here, and I know that these are pi over 6s again, because the other ones were. Now, I'm going to set it up just to be extra positive. So cosine is adjacent over hypotenuse, and then this must be a 1. Yup, it's across from a 1, so it's a pi over 6. That's 5 pi over 6 plus 2 pi k. And this one's 6 pi over 6, and then the next one would be down here. So one more, 7 pi over 6 plus 2 pi k. Heavy duty math. These 4 answers. That'll probably be the nastiest thing on the test, something like that. Where could you have factored it at the beginning? Yes, it wouldn't have saved you that much time, but you could have factored it instead of doing this. You could have started by subtracting 3 and setting it equal to 0. All right, now here's the kind where they just straight up tell you, you need to factor and solve. All right, so let's do number 1 together. I'll remind you. See how there's a cosine in both of them? That means you can factor it out. And if you can factor it, you should. I've had other math teachers go, oh, that's a really good idea to say if you can factor it, you should. Because it's true. It's if you can factor it, it usually is the answer. And if you're struggling with how I got the stuff in the parentheses, it's like I divided both of them by cosine. And that tells you to put a 1 there. And this part tells you to put a 2 sine there. Now, I know some of you are going to say, but Mr. Server, you said that we had to have only one function. I did tell you to be able to factor something. Sometimes you have to have only one function. But look, I factored it. It's this times this. It's factored. So I didn't have to have only one function. A lot of times you have to have only one function, but not always. Like I just factored it. So then cosine of x equals 0, and I know that's a quadrantal because there's no triangle with a 0 side. And then this one's 2 sine x plus 1 needs to equal 0. Subtract 1, 2 sine x equals negative 1. And I love that you guys have gotten so good at this that I can just be like, yeah, easy, easy, and then just solve that. Which actually is complicated, but I know you know how to make the triangles and figure out where sine is positive and throw those out. And from there, this complicated thing has just become an afterthought. Yeah, just solve. No big deal. Opposite hypotenuse, one's negative. This one must be also negative 1. Oh, no, wait. No, must be square root of 3. 1, 2, square root of 3. Yeah, that's right. Okay, so then what's across from the 1 is 30, aka pi over 6. But it's not really pi over 6. It's 7 pi over 6. And then a bunch more. 8, 9, 10, 11 pi over 6. And again, I'm just going to stop because I'm sick of it. Plus 2 pi k on both of them. I think next hour I'm just going to tell them. Last hour I did this plus 2 pi k like 75 times. I'm sick of it. So watch out for it in the directions. And I'll add the directions between 0 and 2 pi. Okay, this one, I think it's kind of boring because it's so easy to factor. Because it's already got cosine in both of them. And this one, again, I feel like it's kind of boring because it's going to be so easy to factor. But I sometimes overestimate how good people are at factoring. So let's just factor them. Don't even solve them all the way. Would you just factor them? I think it's really easy. But I also know sometimes it's not so easy for people. Just try to factor both of these. We don't even need to finish them. I know you know. You'd set them equal to 0. Do circle trig. I'll pause while you factor those two. Okay, so cosine x and cosine x makes the cosine x squared. Then you always think sines. Well, that one's negative. No, that one's positive. So I need 2 negatives. I think that really helps a lot. I didn't used to give this advice to do the sines as the second step, but I really think it's smart the more I've done this. So now I just know it's either 1 or 3, and I can put them in either spot. 1 and a 3, and I could switch it, but it'd be like the same thing. So did it really work then? First, it's cosine squared. Outside, inside, negative 3 cosine, negative 1 cosine makes negative 4 cosine. Yay, it worked. That's the factors. Iris, did you have that one right? Excellent. Maybe we can save some time on this one. Did you know to start with 2 sine? Can you tell me the rest of it then? Is it minus minus or plus minus or minus plus or minus plus? And then 5 and a 1. Is it like this? Excellent. I'll check you. The firsts do make 2 sine squared. Yay. The outside and the inside are usually where the mistakes are made. This is negative 5 sine. Oop, I should have an x here. And this is 2 sine x. And negative 5 and positive 2 makes negative 3. And that's right. Yay, you did it right. And again, you wouldn't be allowed to just leave this, but I'm assuming we've done so many practice like this that you'd be able to take this and set it equal to 0, and then you'd end up with sine x equals negative 1, and then that's a quadrantal, and it won't be that hard. And then over here, that you'd be able to set that equal to 0. Oh, wait, this is going to get weird. So let's talk through this one for a second. So it's 2 sine x e minus 5 equals 0. Then I'm going to add 5, and I get 2 sine x equals 5. This is getting weird. And then I'm going to go divide by 2. Sine x equals 5 over 2. Now think about that for a second. What's weird is not only that I have a number that I'm not used to over here, but also that the hypotenuse is tiny compared to the other side. Is that even possible? No, and it's not a quadrantal either, because it's not 1s and 0s. This is important. This was the first time we've seen one like this. So what are we going to do? I'm going to draw it for you again. Here's sine. It's going like this. And they're saying, when is sine ever equal to like 2.5? That's what 5 over 2 is, 2.5. Well, 2.5's up here. When does it ever touch? Never. So what's the answer? There's no solution. It's different than extraneous. Extraneous means I found an answer and the answer didn't work. This is there is no answer. Because if it's ever bigger than 1, sine can't do that. The biggest it can be is 1. So this is no solution. But just for this side of the equation, the other side of the equation totally has answers. That has normal, quadrantal answers. Yes?
Wait, are you allowed to say like undefined?
Yes, I would allow undefined. The one word I wouldn't want you to say is extraneous. All right. Start that review worksheet, do some more tomorrow and some more the next day. And then Thursday, we will wrap it up. And your test is Friday. Have a great day.